All right. Thank you so much for having me. My name is Jan, and I'm a co-founder and CTO of Macrocycle Technologies, where we're making circular plastics with zero carbon emissions. So we truly have a love-hate relationship with the plastics, right? We love them when we go into the outdoors, when they service us, when we find something cute for our children. And we hate them when we see the massive impact that they have on the environment, where most of the plastics really go unrecycled into landfills, incinerated, contributing to about 6% of global CO2 emissions from the entire plastic supply chain. It's really a linear economy that is only poised to grow in the billions of dollars, harming our planet and ourselves. So why is this not working? Well, the bottles are collected, but only 10% of the bottles actually go back to bottles. Why is that? Well, the truth is that the recycling systems and the collection systems are too dirty that mechanical recycling, which is established today, can handle them. So it leads to darkening of the colors, production of volatile impurities that are toxic, and bottle blowouts. So most of the PET bottles are actually turned downcycled into fibers and strapping, and that gets incinerated and never recycled again. New technologies, like chemistry-based technologies, enzymatic, they can solve the problem of quality and derive high-quality PET materials. However, these processes are all too expensive. They all rely on full breakdown of PET back into monomers, which is a very complex mixture that has to be separated and then plugged back into the petrochemical supply chain to make new polymer. That is pretty expensive, and we've seen companies in this place go out of business. That's where Macrocycle comes in. We're disrupting the space by never breaking the polymer down. We take the polymer, the beautiful PET molecule, and keep it entirely intact, only tying it with a self to make macrocyclic oligomers that can then selectively be extracted from the impurities and non-PET substances to make the long polymer chain again and provide high-quality PET resin with lower cost and lower CO2 emissions. How does the process work? We can take a variety of textile and bottle waste materials and remove typical impurities like PVC, polystyrene, labels, cotton, etc., even from textiles. The polymerization takes place, and we can remove the color. That is what produces a virgin-grade PET drop-in solution for customers and bottlers and packaging organizations like we have here to make new bottles immediately without changing the process. Which is why I'm very excited to talk about this project that we have with Danone in the 100+ Accelerator. We've looked at various contaminated plastic waste feedstocks and really scrutinized the impurities that we find and proven that our process removes them to arrive at a virgin-grade PET material. We looked at color, metals, volatiles, and PVC and the like. But now, people want more. People are not only excited about the quality of our process, but also the carbon reduction. Since we're using more than 5 times less energy than virgin-based PET oil-based production, we can reduce carbon emissions by 80%. Plus, the entire process can be electrified and therefore generate a zero-carbon PET for the first time. This is a process that can abate half a gigaton of CO2 emissions by 2050, as verified by our partners at Breakthrough Energy. And we're in this scaling journey pretty rapidly. We've incorporated 2 years ago at MIT. Since then, we've built a lab and a pilot near Boston in the US. And we're already now at the time where we can produce large enough quantities to work with customers to make the first macrocycle bottle. It's an exciting time with 10 revenue-generating paid trials going forward. And the scaling journey continues. We want to build a real macrocycle chemical recycling factory by 2029. But we have one specific advantage to our competitors. We do not have to build an expensive demonstration facility. We have a chemistry innovation, not an equipment innovation. So we can actually plug this in to existing chemical assets, and we found a contract manufacturer who will run this process for us, producing enough batches for the pilot trials that we're targeting with customers here in the audience in the future. Then, by 2029, we'll be at a facility that can provide PET resin at cost parity in the market. That is a critical piece which very few others can achieve. Beyond that, we are going for selling plants, from selling plastic to selling plants. And with that, I want to introduce the fantastic team that we have. My amazing co-founder, Stuart, who some of you have met at the kickoff event here. I met him at MIT. He came from ExxonMobil, seeing pyrolysis as a technology that has limitations firsthand. And we've teamed up and hired a great team of polymer engineers and business professionals who've been in this industry long before we have, actually. We're joined by our fantastic board members from the investors of the $6 million seed round, and we're advised by people that have tremendous experience. So we can only solve plastic together. We need partners that are excited about chemical recycling at low cost of PET. Talk to me afterwards at the booth, which is the one right next to the entrance, to talk about pilot projects. And if you're an investor and excited about the space, join us in this rapid growth so we can stop hating and start loving our plastics once more. Thank you very much.